Hello and hi everyone. Have you ever thought about how a professional basketball player managed to shoot every single time? Is there any difference between shooting at close and long range? To answer these questions, let's learn about projectile motion. By the end of this lesson, you should be able to describe projectile motion, launched at an angle, as well as special cases when theta equals 0 or theta equals 90 degree. Generally, it can be divided into three cases. Case 1, object launched at an angle, and undergo full projectile trajectory. Case 2, projectile motion launched horizontally or at angle equals 0. Case 3, free fall motion. Projectile motion is defined as a motion where the projected object travels at uniform velocity, in horizontal direction while at the same time, undergoing acceleration in the downwards direction, under the influence of gravity. Here are some examples of projectile motion, in our daily life. We could clearly see the parabolic trajectory, especially in sports. By adjusting how much force to apply, point, and angle of release, a basketball player could manipulate their shooting range in order to score. Previously, we have learned that velocity, acceleration, and displacement are vector quantities. Therefore, projectile motion consists of two components: vertical component, or also known as y component, and horizontal component, or x component. Now, let's learn about projectile motion in details. Case 1. Full projectile motion. Consider a ball is launched upwards, at angle theta to the horizontal, with an initial velocity u. The ball will then move in parabolic trajectory, as shown in the figure. As it moves upwards, the vertical component of velocity will decrease, as shown by the velocity vectors. Once it reaches the highest point, the vertical component of velocity becomes 0. As it starts to fall downwards, the vertical components of velocity increase, with acceleration of -9.81 meter per second square. It is important to note that, horizontal component of velocity, remains constant throughout the course of trajectory. Therefore, horizontal acceleration is 0. Once the ball hit the ground, vertical displacement of the ball is 0. Previously we have learnt equations of linear motion. These equations can be adapted in order to find the instantaneous value of velocity and displacement of the ball in both horizontal and vertical direction. Case 2, horizontally launched projectile motion. Consider a cannonball, launched horizontally from a very high cliff with height of h and initial velocity, u. In this case, vertical component of u is 0. The ball then moves downwards in the trajectory as shown in the figure. As it starts to fall downwards, its velocity is negative. The vertical components of velocity increase, with acceleration of -9.81 meter per second square. When the ball reaches the ground, vertical component of displacement, sy is -h. Case 3. Free fall motion can be defined as a linear vertical motion, under the influence of gravity, without air resistance. Some examples of free fall motion are, when an object dropped from a height, or tossing a coin to the air, and let the coin falls back. All free-falling objects on Earth always accelerate downwards with a constant acceleration, known as acceleration due to the gravity, or gravitational acceleration. Its magnitude is -9.81 meter per second square. Note that it is negative, as its direction is downwards. Here is the summary of projectile motion for your reference. Later, in your tutorial sessions, you are required to solve kinematic problems related to projectile motion. You may refer to this summary to help you. Thank you for listening, wishing you all the best.